Okay, so welcome to this video on decomposition forecasting. And decomposition forecasting is essentially a regression analysis combined with slight modifications or enhancements, but we definitely need regression analysis. So the purpose of decomposition forecasting, as the name suggests, is to forecast. And to see what it entails, let's just go through an example. So below we have quarterly data in the table for 3 years. And let's first plot the data into the graph and estimate the trend line. This is what we then do with regression. And then let's try to intuitively forecast 2 more years. Okay, so on the x-axis, remember, it starts not at 0, but at 1. And we always have 4 quarters. So let's say the first observation, let's make a big dot, let's make it in red. So the first observation at 1 is 5. So let's put the dot here. Then in period 2 it's 10. So we make a dot here. Then it's 11. Then it goes down to 4. Which is here, so at 4 it's 4, and then again 4, and then 12, 13, so I gotta be careful. Okay, 12 is here, 13 is here, then it goes down, that's a little bit bigger, then it goes down to 6. In period 8 it is 6. So that would be here. Then it's again 6. And then it's 15 and 16. Okay, so this is 15. And then 16. And then in period 12, the last one, it is 9. Okay, so this is what our data looks like. So, and if we were to fit a trend line, we would probably come up with something like, let's do something like, maybe something like this. So maybe 6 plus 1/2. So let's assume this is the trend line. If we just try to fit it, and let's dash it as we normally do. Dashes, okay, and maybe different color. Okay, so that would be the trend line. But we can see now the problem that this it's probably not a very good prediction, because we don't want to predict on that line, because technically there's really nothing on that line. There's not really many observations, if any, on that line. So the problem that we have here is that we have, it looks like we have a strong cyclical pattern, and that becomes clear when we combine all those lines. So let's maybe combine all those lines with a thin line, and then the first one would be from here to here, and then this one, then this one, then this one, then we go up again, this one, then we go up again, we go down again, up again, up again, down again. So you see, we see a cyclical pattern, and forecasting on the trend line would probably not capture that at all. Well, it won't. So what we need to do in decomposition forecasting is, not only do we need to work with this trend line, but we try to identify seasonal patterns. And if we take a look at the quarters, so let's say this is always quarter 1, and then quarter 2, quarter 3, quarter 4, quarter 1, 2, 3, 4, 1, 2, 3, 4. So what happens here is that whenever we have a period 2 or 3, which is like spring and summer, it seems that we are above the trend line. And whenever we are 1 or 4, which is actually 2 and 3 would be spring and summer, so 1 would be winter. Actually no, 1 would be spring, summer, fall. So summer, fall is always above the trend line, and spring and winter is always below the trend line. So it looks like that there is a seasonal pattern. So what we try to do in decomposition forecasting is to capture that seasonal pattern. Okay, so here's again what the data looks like, and in fact when we estimate the data, we do get 6 plus 0.5 xi. We could calculate the data now manually using our formulas that the slope is the covariance over the variance of x, but let's just quickly confirm it in Excel. So those are our observations. That will be the x-axis, and on the y-axis we have our sales. Okay, and just to see what we get, so in Excel I already generated the regression output, but just to verify the intercept and the slope. So let's begin with the slope. So it gets the covariance between x and y, close parentheses, and now we divide by the variance of the x-axis, so those are the observations, and we get indeed 0.5, and the intercept, so to remember, is the average of all the y's minus the slope times the average of all the x's. Okay, that's wrong here. Okay, so I forgot that. And that is indeed 6. So the average minus the slope times the average of x. Okay. So this is how we could calculate it in Excel or using the formulas. If we draw it, we can see that we have indeed this cyclical pattern here, and we want to make it a little bit nicer, maybe format axis on tick marks, and then we add the trend line, linear, and then more options, maybe display equation on chart, and then we have here 6 plus 0.5x. Okay, but the forecast would not be really useful because it will not capture any cyclical pattern. So decomposition forecasting helps us to identify that cyclical pattern. And in order to identify that cyclical pattern, what we do, and that is actually step 2. Step 1 was to calculate the trend line. So now we have step 2 in decomposition forecasting, which is to identify that cyclical pattern. And in order to identify that cyclical pattern, we first create a column and call it sales head, which is the predicted. And okay, so this is from the available data. So technically I can expand that by another 3 years. So what I start now with 13, that is a forecast, that will become a forecast period. So we do fill the cell, and I want to stop at 24, and that is becoming a forecast period. So okay, so this light orange is becoming a forecast period, and the only thing we can project in the forecast period for now is this formula. So equals 6 plus 0.5 times the period. So at period 1 it starts at 6.5, but remember we don't display the 0, so that at 0 the intercept is 6. Okay, so now these are our forecast values, but again they do not capture any cyclicality. So again this is forecast. So next what we try to identify is actually the difference between the actual value and the forecast, and we call that sales over sales head. So let's create a new column, sales divided by sales head. So now we can see, as we said earlier, in period 1 it always seems to be below the average. So if we do sales divided by sales head, we should get something less than 1. And whenever it's period 2 or 3, summer or fall should be above. Sorry. Okay, so we create sales over sales head. Okay, so let me see, this is like roughly 25% below the trend line. Okay, it's 23% if we round it. And now we do that for all our observations. And we see whenever it is the first period, which is period 1, the first quarter, but then again the 5th observation is again the first quarter of the second year, and then we have again 2, 3, 4, then the 9th is again the first observation of the third year. It's always below the trend line, and it's always like here it is 23% below, and then it is 53% below, and then it is 43% below. And whenever it is the second or the third period, like summer and fall, it always seems to be above. So now what we do is we just average that out. So, and then we create so-called seasonal indices. Seasonal indices. Well, the seasonal indices are simply the average of all the first quarter observations. So for the spring period, which is, let's say, the first season, okay, we take the average of the first quarter of the first year, first quarter of the second year, and first quarter of the third year. And that tells us that on average, whenever there is a first quarter of the year, the sales are 40% below the trend line. So now I can copy down that formula, and we see that whenever it is above the trend line, whenever it is the second or the third quarter, so summer and fall, then it's above the trend line, and in the fourth quarter, winter, it's again below. So those are the seasonal indices from the available data. So now what we do in decomposition forecasting, we'll just copy that into all the other periods. Okay. So but you gotta be careful. You have to just use the formula once, calculate the seasonal indices, and then assume that those seasonal indices will prevail in the future as well. So, okay. So we only calculated something here in the first, and then we just projected those seasonal indices, right? So maybe let's highlight that or make that sure that this is a cell style, which is a calculation we had to do, and then we project that one. Okay, so now what we can do is we just can create the forecast, and the forecasted value is, maybe put that graph down here now. So now the forecast is equals to, so now we take the estimated value, the sales head, we basically take the trend line, but now we adjust it by the seasonal indice. So that means we multiply the predicted value times the seasonal indice, and I can do that now including to the forecast period. So, okay, that needs to go down here. So, okay, and we don't need to show all those values. Okay. Oops. I just want to remove some of those decimals here. Okay, so this is now our decomposition forecast. Maybe I should call it decomposition forecast. So what you see is we basically weigh the predicted value based on a trend line just by those seasonal indices. Okay, so we have step 1, step 2, and step 3. We calculated the seasonal indices. And here I display always 3 decimals so that you can see. Let's add another decimal point in here as well. Okay, so now we have our seasonal indices. So then the next step is we calculate the forecast. And then we also calculate the so-called MAPE, which is the mean average percentage error. But before we do that, let's now take a look at what our decomposition forecast actually looks like. So we want to display the observations, then the actual sales. Of course, there are like nothing after in the forecast period, which begins at 13. Then maybe the trend line, we want to show this one. And then we want to show the decomposition forecast. And we want to show that all in one graph. So let's go to Insert, Recommended Charts. Okay, so all charts, maybe a line chart, but that looks right. And this is our decomposition forecast. And we can see the orange, that's the predicted on the trend line. There is a blue line, which is maybe not the best color to see. So let's give that a different color, maybe let's make that maroon, and the green maybe something like this. Okay, I hope that has enough contrast. So we see the decomposition forecast is obviously much better than at the trend line. And it picks up that cyclicality that we have observed in the data, which is what a regular trend line could never absorb. Well, so next what we can do is we can calculate the so-called mean average percentage error. And this is, we just take the mean absolute percentage error, so we calculate the absolute percentage error as the actual minus the forecast, and that should go in parentheses here, relative to the actual value that we have. So divided by the actual, and it's all in absolute terms. So what we do in Excel, we would say this is equal to absolute, and then we take the difference between, let me put that in parentheses, between the actual sales minus the forecast divided by the actual. And of course we can only apply that to the range for which we actually do have data, which is excluding the forecast period. Okay, so the first one seems to be 21%, and then we can just copy that down for our 12 observations. And now we can calculate the MAPE, which is just the average. So the average of all those mean absolute percentage deviations, or the average of all those absolute percentage deviations, is 0.096 or 9.6%. So that is our MAPE. And we could now, of course, if we did now the same, if we calculated the MAPE based on the trend line, so that would be the alternative, which you don't see here on the slide, but so this is the MAPE based on the decomposition forecasting. I could also do the MAPE based on just the trend line. I called it then just to see the trend line. So then we would say the difference between absolute. So now if we compare it with the sales head minus the actual sales divided by the actual sales. You see, so now so if we take the average of this one, we obviously should get a much greater mean absolute percentage error, much higher MAPE, and that would be actually 49%. So you can see how decomposition forecasting reduces the error in the estimates. Okay, so let's see. Here's just again a final slide where we can show again, maybe a little bit better and in different colors, the same graphs. And we can see how the decomposition forecast matches nicely the actual data. So in summary, in decomposition forecasting, we typically have like 5 steps. First, we calculate the trend line and forecast over the forecast period. Then we calculate the ratios of the actual to the predicted values, in our case, the sales. Then we calculate the seasonal indices, and then we project those seasonal indices into the forecast period, and essentially all observations. And then we apply decomposition forecasting by multiplying the y-hats, the predicted values, by the seasonal indices. It's like a weight. And then we evaluate our model based on the mean absolute percentage error. Okay, so I hope that this made decomposition forecasting clear, and in the next video we'll have another look at the problem set. But let's just stop here, and I hope to see you in the next video.